Hi everyone, my name is Mehmet Salih Kavak. I'm a freshman student at Bilkent University and I am studying Electrical and Electronics Engineering department. Today I will present my Physics 102 final project. My project is about Faraday's law of electromagnetic induction. The purpose of my experiment is to examine effects of the number of winding and area of coil on induced electromotive force, measure magnetic flux change per unit time with associated errors, and analyze whether the number of winding has an effect on magnetic flux change per unit time. A multimeter, a ruler, a magnet, crocodile cables, scientific calculator, and stopwatch will be used. In addition to them, three coils which have 20, 50, and 80 winding respectively with radius 0.03 meter and three coils with 0.02 meter, 0.003 meter and 0.04 meter radius respectively which have 20 winding will be used for this experiment. To explain experimental setup, I fixed a ruler in a place and taped the coils to ruler. I connected coils tips to multimeter and then I dropped the magnet through each coils. If your equipments are ready, we can start. In the first part of the experiment, I wanted to investigate how the number of winding influences electromotive force. In order to do this, coils which have 20, 50, and 80 number of winding are applied to experimental setup. I dropped the magnet through these coils and I measured the induced EMF through multimeter. Later, I recorded these measured data to suitable tables. As you can see in these tables, we can conclude that there is a correct proportion between winding and EMF. I also wanted to compare the data obtained with theoretical values. In order to compute theoretical values, I used the formula minus n times dB over dt times a times cosine theta. Since negative sign represents the direction, I just recorded their magnitudes. When I compared them, I encountered some errors which are 3.70 and 12 and 9.30% respectively. They may arise from some reasons such as failing to achieve a perfect right angle, not providing a smooth circle, measurement errors, and external electromagnetic interferences. Additionally, in this part, I wanted to show you that the magnetic flux change per unit time does not depend on the number of winding. In the second part of my experiment, I wanted to investigate how the cross-sectional areas of the coils influence electromotive force. I applied the coils with 0.02, 0.03, and 0.04 meters radius to experimental setup and I dropped the magnet through the coils. As you can see in these tables, I wanted to compare and analyze how area affect induced EMF. Firstly, when I analyze, it can be said that there is a correct proportion between area and EMF. Also, I encountered some errors which are 10.2, 12.0, and 11.1%. These errors may arise from measurement errors, human factors, external electromagnetic interferences, and temperature effects. That was my experiment. Thanks for watching.